Hi, my name is Jung-Hoon Sun, here today to give you a brief overview about my Kaggle competition entry for Gemini long context. So one of the main challenges of clinical NLP nodes is that there's so many ways to represent a concept. So abdominal pain could be someone saying tummy hurts. And there's tons of jargons and shorthands like PTW/SOB, patient with shortness of breath. Say we're given this very simple prompt of if we were to do map SNOMED codes or UMLS codes, this is what it returns. And at a first glance, it looks like it did a lot of the task right. But the problem is that the code itself that it generates is hallucinated codes or fabricated codes. So literally what I ended up doing was to write everything out as a sentence. If you look at the second portion, anterior spinal artery stroke is an arterial disorder. And also references to other terminology. So ischemic stroke can be coded with the SNOMED code and this UMLS code. So after we transcribe everything into plain language, and it really looks obnoxious at a first glance, but as we do this, try to make it parse the exact same text and make it return a very structured report of the source of the data, and then give a supporting evidence based on the cached ontology. So one of the cooler things to see on the example page notebook is to check some of these structured reports that are being generated. So this is a very complex patient with new onset pancytopenia, splenomegaly. It's a classic case, but it's a chronic myeloid leukemia with some translocation, and all the supporting evidence based on the ontology findings are listed here, which is nice. And the highlights actually suggest that these are actual concepts, which is really hard to do, showing that like 92% blast is suggestive of blast crisis. Making this LLM entity linking directly from pictures as well. I first asked Gemini, describe this lesion as if you were a doctor seeing the patient. Basically, take that descriptive output and feed it back into LLM ontology entity linking pipeline, the exact same prompt that I'm going to use. Because now it has a description of the picture, starts tagging things. So we basically went from image to, I guess, like ontology concepts directly. So it's like a pretty cool thing to see that its conceptual framework is working. It doesn't stop at just pictures of lesions. You could also do this with radiology if you have a powerful enough agent. So I assume Gemini could do that. So these are a picture of an x-ray with some sort of a consolidation. Let's see what the Gemini says. So it's radiology report finding impression, atelectasis or consolidation on the left lower side of the lung. Also suggestive of like early interstitial lung disease as well. This is another picture, patient with like very subtle, not so subtle, but something that mimics stroke sometimes, called Bell's palsy. And it's a photo of a male face with concerning for right cheek cellulitis and asymmetry. Recommendation that it's associated with Bell's palsy, Lyme disease, and other things. It's able to come up with a diagnosis purely on the descriptions of the image. I just fed it in a picture that I found of LeBron James to see what this pipeline actually did. So same thing, describe this picture as if you this is like, assume that this is a medical image. Guess what it did? It says it's a standard photograph of a basketball player, LeBron James, taken during the game. And like it doesn't comment on anything else except body parts, like arm is part of an upper limb. So it's like very interesting to see that it doesn't like forcefully try to make a diagnosis. So as much as it's not like a very flashy project, but I think it has many use cases for a lot of folks in healthcare and life sciences. Thank you.